Hi! Within this class, we are going to explore and know more about the second phase of the Amazon FPGA image creation flow. The first phase we went through was the kernel creation phase, but what after an XDXL kernel has been created? This is when the second phase of the Amazon FPGA image creation flow comes into play. This phase is known as the platform compile assemble phase. The objective of this phase is to compile the platform, which means to generate the FPGA binary. During this phase, SDXL compiler is used to link together the SDXL kernels created during the first phase with other required hardware components to generate the FPGA binary. After all the necessary SDXL kernel has been created, starting as we know from either C, C++, or OpenCL or RTL models, the compiler creates hardware kernels with the necessary XE interfaces, and it automatically generates the SDXL kernel packages, the XO files. Once we have all the XO files, the following step is to assemble the overall FPGA design. The kernels are key component of our design, but they are not the entire design. They can be considered as components used to implement specific parts of the design, but they have to be embedded into other hardware components, such as the F1 shell. And this is exactly what is happening in this phase. The SDXL compiler reads all the XO files and automatically instantiates the kernel and the F1 shell. As we know, the F1 shell allows for faster coding of acceleration by removing the need to develop I/O-related FPGA hardware and exposes predefined XE interfaces, which is exactly what is going to happen now. The SDXL compiler automatically generates the DDR interfaces and creates the XE interconnect logic to integrate the custom acceleration kernels. We are close to the end of this phase. Well, better, we are close to the creation of the final assembled FPGA design. In fact, the compiler makes all the necessary wiring and connection, which results in the desired completely assembled FPGA design. Once we have the final assembled FPGA design, XDXL runs synthesis and place and route on it. These phases are used to obtain the final physical design of our system that has to be implemented on the FPGA. At the end, what we are going to obtain is the FPGA binary in the form of the xclib bin file. Because of timing goals, just as an example, multiple iterations might be required to converge on an optimal design. Therefore, it's important to know that this phase may require a lot of time to be completed. For best results, I'd like to remind you that kernels should be designed with the recommendations from the Ultrafast Design Methodology Guide for the Vivado Design Suite. This concludes also the second phase of the Amazon FPGA image creation flow. Within the next lesson, we are going to see the third and final phase, the Amazon FPGA image creation phase.